Hello, Algebra 2. We are going to go ahead and take a look at arithmetic and geometric sequences. I actually want you guys to try this one on your own, but just to set this one up for you at first, think about a pyramid of logs, and it has logs, like real wood fire logs, not the log functions that we were just learning about, but real fire logs, like wood pieces of log that you put in the fireplace. Has two logs in the top row, so I've got two logs up here. Here's one log, here's another log. And then four logs in the second row. So now we've got 1, 2, 3, and 4. And then I've got 6 logs in the third row. And this is going to continue, okay? The next 2 days are going to be all about patterns. So there are my 6 logs in the third row. And so on until there are 200 logs on the bottom. So this is going to go on forever until you have 200 logs at the bottom. Right now I only have 2 logs, and then I have 4 logs, and now I have 6 logs. So think about what is the relationship between the row number. So like in the first row I have 2 logs. Second row I have 4 logs. Third row I have 6 logs. And how many rows are there in the pyramid if I have to get to 200 on the bottom? All right. A way to get started is once you figure out that relationship, then you could figure out how many logs are on any row. So for example, if you were asked how many logs are in the 37th row, you'd be able to figure it out. One way that might help you organize is if you make an XY column, and let's say X is the row, and Y is the amount of logs that you have, right? So in my first row, I have 2 logs. In my second row, I have 4 logs. In my third row, I have 6 logs. And this is going to continue until we have 200 logs. And I don't know how many rows that actually is. So see if you can figure out the relationship and tell me when I see you next class. Until then, we are going to look at patterns. And all of these examples that I give you guys first, there's some kind of relationship, some kind of pattern. And anytime that you're listing numbers that are sequential with the same pattern, they're called a sequence. So our sequence is just a bunch of numbers listed, but they all have the same relationship. We do the same thing to get to the next number. So if you look at 2, 5, 8, 11, 14, you can go ahead and pause here, see if you guys can figure out the relationship to how to get from the first number to the second number. Once you have a chance to look, you'll notice that this one, you're adding 3 every time, right? 2 plus 3 makes 5. 5 plus 3 makes 8. 8 plus 3 makes 11. 11 plus 3 makes 14. So this one is adding 3. For number 2, from -1 to -2 to -4, 8, 16, it looks like I'm multiplying by 2. So let's say I multiply by 2. -1 times 2 makes -2. -2 times 2 makes -4. -4 times 2 makes -8. -8 times 2 makes -16. So here it looks like we are multiplying by 2. In number 3, I believe we are actually missing one number. You probably realized a relationship. 1 squared is 1. 2 squared is 4. There should be a 9 in here. Sorry for missing that one. So 3 squared is 9. 4 squared makes 16. 5 squared and 6 squared makes 36. So you are squaring each number. All right, to get the actual numbers in our pattern. And then last but not least, to get from 2 to 3, we're adding 1. To get from 3 to 5, we're adding 2. To get from 5 to 8, we're adding 3. To get from 8 to 12, we're adding 4. So what do you think we'll add next? Right? To get to our next number, we'd probably add 5, and then 6, and then 7. So we're adding 1 more each time. Okay? So when you're listing a sequence, you'll notice that there is going to be a pattern between each number and how to get to the next number. We call n the actual position of the number in the sequence. The position, right? So if n is 3, we're talking about the third number in the sequence. And then a sub n is actually the value of that nth position. So for example, if you were looking at, let's look at number 4 above here, okay? If I said n is 5, if n is 5, then I would be looking at the 1, 2, 3, 4, 5th number. A sub n would be 12, because that's the actual value of the 5th number. Okay, so n is the actual position of what it's in, so 12 would be the 5th position, 8 is the 4th position, 5 is the 3rd position, 3 was the 2nd position, 2 is the 1st position, and then a sub n is the actual value of that position. So when you guys are looking at this example, we're going to start with a new example, okay? A sub 1, 1 would be the 1st position, so that would be -7 in this case. A sub 4 would be the 4th position, so 1, 2, 3, 4. And then it says when a sub n is 18, what is n? Remember, a sub n means the actual value. So here's the value. That's 18. So we're looking for n. N is the position. 1, 2, 3, 4, 5, 6. It's the 6th position. Okay, so n would equal 6 there. Use the recursive formula. So we are going to take a look at your formula sheet. And what you'll notice on your formula sheet is that this set right here is your sequences and series formulas. And it tells you a sub n represents the nth term. We're going to learn the s's and the r's and the d's in just a minute. But what I'd like you guys to look at is the very first one and the second one. These two are what we're going to focus on today, and then we'll also look at these two. So the first two, the ones with the a sub n, not the ones with the s's yet. We're going to talk about those next time. But the a sub n one, this second one here is called the recursive formula. A sub n equals a sub n minus 1 plus d. Because all it's doing is taking the previous number and adding the same difference. So d represents a common difference, as it says right up here to remind you. So we're going to use this formula, the second one right here. A sub n equals a sub n minus 1 plus d. So the recursive formula is a sub n equals a sub n minus 1 plus the common difference. Okay? An arithmetic sequence is a sequence with a common difference. And the equation for the arithmetic sequence is the other one we were looking at. This first one here, a sub 1 plus n minus 1 times d. So we're going to go ahead and use that one as well. So we're going to use the first term plus n minus 1, so the position minus 1, which is the first position, or the position before, multiplied by the difference. Okay? So let's look here. Write the equation for the nth term of the following sequence. So for this one, if I'm using this first recursive formula, to get the nth position, I would need to use the first position. So I'll say -5 plus the common difference. Well, what is the common difference? To get from -5 to -2 and 1 and then 4, it looks like we are adding 3. So d would be our 3. That's our common difference. Okay? And to get the next number, -5 plus 3 would give me -2, which it does. So to get from -5 to -2, I have to add 3. If I use this formula here, this would say to get to whatever position you want, you have to take the first one, so -5, plus, well, it depends on which one you're trying to find. So for example, whatever n is, let's say I want to find the third position, I would have to make n 3. If I wanted to find the fourth position, I have to make n 4. So it just depends on what position you want is what we're going to use for n. And then I multiply by d. I know my common difference is 3 because I'm adding 3 every time. All right, this one would be the same. Let's say, for example, so for this one, I would set up, I'm just going to use n because I don't know what position I want to find. So we're going to use the previous term. So for example, if I want to find 16, I would use 22. And for this one, it looks like I'm subtracting 4. Oh, nope, I'm subtracting 6. That's what I meant. Same thing here, subtract 6. Okay, so my common difference is going to be negative 6. So I would have to take the original number, a sub n minus 1, so whatever the number is before the one that I want, and I'll have to subtract 6. That's if I use the recursive formula. If I use the other formula, you're going to get the same answer, but it says to use the first number, so 22, plus whatever position you want, minus 1, and then multiply by the common difference, which is going to be negative 6 in this case. A geometric sequence is a little bit different because a geometric sequence is where we multiply. So it's a sequence with a common ratio. Let's take a look at your formula packet again. And here is our formula for common ratio. Again, the second one is the recursive, where you just take the number before and you multiply by whatever your ratio is. Or if you're trying to find a specific term, we're going to use a sub 1, the first number, multiplied by the ratio raised to the n minus 1. So let's go ahead and use that one back here. So whatever term you want to find, it is your first term multiplied by your ratio raised to the n minus 1 power. So for example here, I want to find the nth term. So in other words, I don't know which term I actually want to find. Could be the fourth, third, fifth, doesn't matter. What I do need to figure out though is what I'm doing to get to the next number. And here it looks like I am multiplying by 3. Since I am multiplying, that's what makes it geometric, because geometric has a multiplication, it's a ratio. So I have to multiply or divide. No more adding and subtracting like the arithmetic one did. So for this one, I would use whatever term I wanted to find. And the first term, a sub 1, is 2. My ratio is 3. I'm going to put that in parentheses. And I'm going to raise it to the n minus 1. Again, the n is dependent on which term you want to find. For this one, I would do the same thing. Now this one looks like I am dropping. I start at 48 and I go down to 24, and I go down to 12, and then I go down to 6. So in order to find that ratio, it's probably going to be a fraction. So the way that I can do that is I can take the second number, 24, and divide it by the first number, 48. That reduces down to 1/2. So I know that my common ratio is 1/2. If I multiply 48 by 1/2, I get 24. If I multiply 24 by 1/2, I get 12. If I multiply 12 by 1/2, I get 6, and so on. So my common ratio, R, is 1/2, whereas here, if I took 6 divided by 2, the second number divided by the first one, I would get 3, which is what my common ratio was here, was 3. Okay, so to write my formula, whatever n I want to find, let's say I want to find the 10th term, right? If n was 10, then I would use 10 there. I still have to use my first number, a sub 1, which is 48. I multiply by my ratio, which is 1/2. Remember, all this is coming from the formula. And then I raise it to the n minus 1. N minus 1 is dependent on what n you choose. And there's my formula. We are going to do several examples of these in class tomorrow. For this first example, though, you'll notice there's a common difference of 3. So if we use our difference as 3, it asks us to find a sub 8, so our n is 8. Our first number is 3, plus n minus 1, so 8 minus 1, multiplied by our difference, 3. You wind up with 24. Go ahead and try the next 3, and we'll check them in class next time.